Okay, so yeah, so last year students said they wish they had some practice for the midterm exam, and so I'm going to just for practice I'll give you the exam I gave in the spring, okay? Just so you kind of have an idea, and this quarter's exam will be sort of similar. I don't know. In the idea that I'll provide links to a data set or at least some data, and you'll import the data and load that up into you'll create a Jupyter. Well, I'll provide kind of like a baseline Jupyter notebook to get started, and then you'll get the data in, and then I'll have questions related to it. So, for example, last quarter's midterm exam used data from the CDC, so Center for Disease Control. They do a survey called the National Health and Nutrition, Examination Survey or something like that, NHANES. And basically, they do all sorts of stuff and take all sorts of measurements. But here, and there's lots of information that they collect. But here, I was just curious about body measurements. Okay, body measurements meaning like with the sample that they select, they measure things like your head circumference and how tall you are and how long your forearm is and all sorts of stuff. They take a lot of other like nutrition information and stuff about what's happening in your home. They also collect demographic information, and so everybody in here, you can read up about this. This was last year's midterm, so I've got a different data set for this year's midterm. But anyway, they took this, and then in the questions I asked were things that were I don't know. I thought reasonable questions. Okay, and the way the midterm exam will work, it's going to be like a take home, in that so it'll be 1 week from today, and at like 3 o'clock I'll upload the questions for the exam. So probably on before Friday of next week. So probably like Wednesday or something. I'll upload the data files and like your starting Python notebook, okay? And this will just at least read in the data files and at least get the data in, and then but I won't have any questions. But you can at least, like, between Wednesday and Friday, you can just kind of familiarize yourself with the variables that appear in the data and stuff like that. Okay, so you can so on Wednesday you can start kind of playing around, and then on Friday I'll put the questions up, and then and basically there's no restrictions on what you can do, other than you can't talk to other students about the exam. Okay, so you have to work independently. Okay, but if you want to go online to look for help and documentation, that is open and available to you. Okay, it's just if there's if I catch any whiff that people were working together or collaborating, then there's going to be I'll have to open some kind of case up with the university administration. I don't want to do that. It's a painful process for everybody involved. So just don't talk and work with other students. We'll be fine. Okay, but it would be I start off with kind of a guiding question, like, do baby boys weigh more than baby girls on average? That was kind of a question that we asked, and then I broke this down into little tasks that you need to do in Pandas. So one would be calculate and display the mean weight of baby boys for each month from month 0 to 12, and you'll produce 13 values, one for each month. And so that would require you to, so the NHANES data has data on individuals, and so this required, you know, kind of some grouping up of data, well filtering down to boys and filtering just to I guess the ages 0 through 12, and then you know, finding the mean weight of the boys for each of those months. Okay, and then, you know, do the same for the mean weight of baby girls for each month. Calculate and display the difference between the mean weights of boys and girls for each month, and you know, make a line plot showing 2 lines, one for the boys' mean weights 0 through 12 and one for the girls' mean weights. And all of these tasks, I think they are straightforward, but then I encourage you guys to try it out and get some practice and see, you know, because I think a lot of students struggled, and I think a lot of students were surprised at the struggle because they felt like, you know, these are straightforward tasks, but then when they were faced with actually carrying it out in Python, they realized they weren't as familiar with pandas as they might have thought going into the midterm. So so definitely practice, and I think that's how you'll get better. Okay. Yes.
Is the data clean?
Yeah, the data is clean. Okay, there's I think you know, I didn't ask the last quarter's midterm to do this, but if I asked you to manipulate some of the data and like form a new column based on something, I feel like that's a fair question, right? Like I don't know, extracting a portion of the text or something based on that. So, you know, that might count as a little bit of data cleanup. I'm not going to give you like totally messy data, okay? Just I think the data I'll provide is good data, but yeah. So anyway, I encourage you guys to kind of try this out. I think probably the biggest struggle is completing the assignment within the 2 hours, and I imagine you know, if you haven't practiced, you know, this might take a little bit longer, but I'm hoping with practice you'll get better. And when somebody says, you know, find the average of these things and calculate these series and stuff, you guys can do it. Okay. All right. I don't know. Are there questions on this? So this will be, you know, my job will be to this weekend is to figure out exactly the questions I'm going to be putting on the midterm. I've got a data set that I think I like that we'll use and whatnot. Okay. So, you know, I think this midterm sandbox should work in terms of getting started, and the way it's going to work is you'll cut that and put it into your kind of the folder where you do stuff. Okay, and so I'll just paste it right here. This is probably not the best place, and then here I'll put it into my practice exam folder here. I already have it here. Okay, so I already have it in there, and then I would download this data file, and you'll want to put everything in the kind of the same folder here. So I got the demographic file and then the body measurements file. It goes all in my practice exam here, and then I'll fire up Jupyter Notebook, go to the folder where I put everything. Fall practice exam. Here's the sandbox. And then let's see if we can just, I guess, clear all this output. So I think if I read that in, so that looks like it read in okay. And yeah, okay, so we have 9,544 rows. And then for, yeah, that also read in okay. 9,971 rows, that's fine. And then I merge them together on sequence number, which is kind of the ID that they've done. Okay, and so I've got 5 rows and 72 columns now. Okay, and then you can start doing work on each of these things. So the part of the challenge, I think, for the last quarters was the data dictionaries were quite big, and so you know, I will post information on yeah, by Wednesday, kind of with the data files, and you can read through the data dictionaries to understand what's in there. Okay, and then here, then you can start playing around with merged. So you got merge.loc, and then in our case we want baby boys. So for demographics table, oops, I think we want gender, RIA gender. Okay, so we got this, and then so 1 is male and 2 is female. So we'll just we'll take this, and you know, you can just start filtering and say merged dot gender is equal to 1. All right, and let's just take a look there. Let's just say take a look at the shape. Okay, so that seems appropriate. Okay, and then 4,600, so about half. So that seems to be appropriate. And then, you know, you'll add additional. So this will just be boys only now, and then, you know, then you can filter down to just the month age in months, which I forgot which column that is, but it's going to be somewhere in here, right? Age in years, age in months of screening. So we can do this. So, you know, however you want to do this. I forget now. Okay, well, we'll say less than. Okay, well, anyway. How many do we have? How many rows do we have now? Okay, 192. All right. So anyway, you can start just kind of mess around and see how, if you can answer these questions. Okay, I think it'll be a good exercise if you play around and practice. Try working through the exam. Okay. All right. Okay. This is. I don't think I put any of this stuff. yeah, I don't think I asked any in the midterm to fit any kind of actual models. Okay, maybe I said, you know, use Seaborn to fit a scatter plot with linear regression lines, but students didn't actually have to perform actual linear regression. But for today's lecture, I'm just doing a very, very brief, I guess, intro into the package stats models, okay? So as far as fitting data in Python, probably the biggest package and most popular package is Scikit-Learn, okay? So probably modeling data in Python. So probably the most popular package is Scikit-Learn. How do you spell Scikit-Learn? We all just, yeah. So that's going to be the most popular package out there, okay? But Scikit-Learn kind of takes a different philosophy and approach to statistical models than probably what you might be accustomed to as a stats major, okay? So, you know, when you took your linear regression course, you know, you learned a lot of, I'm imagining a fair amount of time was spent on diagnostics and then variable selection and things like that, right? And so you produced all these plots, and then as far as variable selection, you probably did like forward stepwise or backward stepwise selection, and you say like, okay, these are all the variables we fit. This one has the least significant coefficient, or you know, and so we'll remove that and things like that. Scikit-Learn is its approach is a little bit more automated, I think, and there's a lot of regression models, or not even regression models, just like a lot of different models you can fit to your data that kind of have almost built-in feature selection or regularization, I guess, features about the thing. So, you know, with Scikit-Learn, you're not going to get your ANOVA table of coefficients and things like that. You'll create your model, and then you'll fit the model, and then you'll ask what the result is with Scikit-Learn. And this works well for you know, just trying to fit a bunch of different models to see which ones perform best, and stuff like that. But a lot of the, I don't know, the traditional statistics stuff, I would say Scikit-Learn is not the best package for that. Okay, we love Scikit-Learn. It's a great package and is useful for fitting all sorts of models, but it's different from traditional stats. Okay, and so so you'll have more like so rather than doing forward stepwise variable selection, you might use something like Lasso Regression. Have you guys learned Lasso Regression? And how there's kind of a Lasso Regression automatically, or not automatically, but it punishes weak predictors and forces the coefficients for them to go down to 0, right? And so Lasso is like a popular model to fit in Scikit-Learn because it kind of performs automated feature selection for you. So I'll just write Scikit-Learn is not the best for a, quote, traditional stats approach. Okay, so today we'll start with the stats models package. Okay, stats models package or library is better suited for traditional statistics. Okay, so the stats model library will give you your ANOVA table. It'll give you p-values and talk about each coefficient and allow you to do these sorts of things. And so they're just kind of, different, I don't know, different philosophies, I guess. Okay. Even Python's library system is quite different from ours, right? So in R, anybody can make a package, and there's a bajillion packages out there, and you have to kind of trudge through and find a good one. And you'll have 10 different things. There'll be 5 different packages that all do neural nets, or 5 different, multiple packages that do decision trees. And there's kind of oh, I use this package or I use this package, and it's a little bit cluttered. Python, I would say there's only a few packages that people use, and everybody uses them. And Scikit-Learn is a huge package or a huge library, and people just keep contributing to different aspects of it. But there's certainly a hierarchy, and I wouldn't even know what else to use if not Scikit-Learn for some of these things. Okay, but stats models is another one, and this is the one that we use for kind of traditional stuff. Okay, you're gonna call stats models. You import statsmodels.api as SM and statsmodels.formula API as SMF. Okay, so you've got the stats models and SMF. So the regular stats models uses kind of NumPy array methodology to fit models, and then stats models formula uses probably the formula notation that we're familiar with in R. Okay, so we'll start off with kind of people coming from R, and then we'll take a look at how things get formatted when you're doing stuff kind of like Scikit-Learn. Okay, so here this is the dumbest example, but I'm going to just have 4 pairs of points. Okay, x goes 1 2 3 4 and y goes 2 6 4 8. Okay, and so we have 4 pairs of points, and then we can kind of plot this using matplotlib, and this is what we have, 1 2 2 6 3 4 and 4 8. Okay, and then this is so small that you could probably calculate the best fit line by hand if you were forced to do so, but we can do this here. Okay, to use stats models, you've got to make a data frame of our data. Let me this should actually get out here, and so to do that, just do it. I did a dictionary with the the name of each column and the array to throw in there. Okay, so here's our data frame that we make. Okay, if you're going for something just simple, you can just use Seaborn. Okay, but again, what happened here? That shouldn't. I don't know why this is complaining. Instead, using a non-tuple sequence. All right, I don't know what this is. Okay, well, anyway. So here it plots our 4 data points, and then it fits a linear regression line, and it also gives us error bars, which are huge, but that's expected because we have only 4 data points here. Okay, and so anyway, this is what we have. But Seaborn is just for visual exploration, and it does not. It won't even tell you the slope and the coefficient of this linear model that we just fit. Okay, so if you want that, we can use stats models. Okay, so again, we're using statsmodels.formula.api. Okay, and so statsmodels.formula.api, and then you can call OLS for ordinary least squares, and then the formula here. This is, I think, our familiar formula notation from R. We're going to say Y as explained by X, and the data is stored in the data frame D. Okay, we're going to store that as model, and if you ask, print model here, all it says is we have an OLS object. Okay, and then and so this just kind of initializes the model and says we're going to make one, and then to actually calculate, to estimate the coefficients, estimation of coefficients is not done until you call fit on the model. All right, and this is this happens. Scikit-Learn works in the same way. Okay, so you use the OLS, or whatever function model that you're trying to fit. You initialize it, and it creates an OLS object, and then after you fit it, then you get something called regression results, or regression results wrapper, and this is what contains all of the kind of the coefficient estimates and stuff like that. Okay, so in R we're just used to calling LM on Y tilde X or something like that, but Python does it a little bit differently. We can still use formula notation by using stats models formulas. Okay, and then and the results is this, and then the table that we go for will be the results.summary. Okay, and so this gives us our OLS regression results. It might be maybe a little bit more than we originally anticipated, but it has all of the information that that we would expect. Okay, so it has number of observations 4. We have 2 degrees of freedom on the residuals because when you fit a line, you're going to use up 2 of them. Okay, and then so anyway, this is what we have. The method's ordinary least model is ordinary least squares. Okay, and then so here we've got the intercept is 1 and the slope is 1.6, and that's fine. Okay, it calculates a p-value for our coefficients, which is not impressive. It's not significantly different from 0, but that's expected because we only have four data points here, right? But so we have a p-value of 0.2. But anyway, these are kind of the values we might expect to see in a for linear regression, along with all of this stuff, r squared and all of that. Okay, and then to plot it, you can use stats models.graphics.ab line plot. Okay, and here all of these things you can look up the documentation. Here we say the model results will be the results that we produced here. Okay, so the model fit go into results, and we're going to produce the thing. If you just call AB line plot here, it doesn't actually plot anything, and you're like, what? I want this. So you actually have to call AB line plot, and then you have to call some kind of plot to put the dots on the screen or something. So here I'm going to do plt.scatter, make a scatter plot of the x and y variables in our data frame D, and then I also just adjusted the axes limits, and so now we have our 4 data points and the regression line thrown in there. Okay. And then if you want to get your ANOVA table, that's also possible. and you can do statsmodels dot stats dot ANOVA, okay, for linear model, and then you'd get the your ANOVA table that you'd expect. You know, degrees of freedom with sum of squares, mean squares, and your F ratio. Okay, and then if you wanted to oops. So generating an ANOVA table, and then making predictions. So here our model results, okay, after we fit the model, is stored in results. We could then use results.predict, right? And then you have to provide it a dictionary with the values that go into it, right? So here we only have one predictor variable, x, but if you had multiple predictor values, you'd provided a, you know, kind of a dictionary of those things, or, you know, you can provide it a data frame of test cases, and here it says our prediction that we would make would be 4.2. Okay, you know, and again, like everything else, you can always go to you can just look up stats models on Python, and you can read the documentation, or under examples, they probably have a lot of stuff, and there's also the examples wiki. So here's for ordinary least squares regression, they've got a bunch of examples here, and then other examples provided in the stats models documentation. So you know, I won't put stats models on the midterm exam, okay? But this is like if you want to use it for your project and things like that, you know, at least I should give you, I feel like an introductory glance at the package, okay? I guess this isn't. Okay. When you use Scikit-Learn, you often have to fit things as you have your predictor array and then your results array as well. Okay, and so in this case, I have, if I just say print x, x is just a NumPy array here, and so I'm going to create capital X, which is going to be a matrix, and statsmodels.addConstant will add a column of ones, okay? Because if you imagine the model being what do we have? We got y is equal to beta 0 plus beta 1 x plus epsilon. I guess x sub I should do x. All right, so you might have something like this, and you might create a matrix X, but this will be it's going to actually be a vector, a matrix of ones. Well, one column is ones, and the other column is the X values, right? Because we can say this is going to be your beta, math bold font slash, actually, it's bold symbol. I don't remember. Okay, you know, beta x, and for this to line up, then x has to be your okay, so you know, if you got y hat being, you know, beta times x, then x has to have the appropriate dimensions, and you need to have this, right? And then so so anyway, for this we have to create our matrix x this way. So we use add constant, and then and using stats models. So without the f, stats models .ols. Okay, so contrast that to up here we had stats models formula smf.ols. Here I've got stats models.ols, and we fit the y values and our x matrix here. Okay, and then so this defines the model, and then you fit the model, and then you can ask for your summary here, and you get basically the same results. Okay, and this would be the same as if I did numpy. So mathematically it's x transpose x inverse x transpose y, right? For coefficient estimates. Okay, this is your OLS solution. So I think I can do this in R. So I have my X matrix here, and then I would have to do x dot t at sign x, and that gives me that, and I have to invert this, and I think that's np matrix mat inverse. Is that right? No. NumPy matrix inverse. Oh, Lin algebra inverse. Okay. X transpose X inverse times at sign X dot transpose at sign Y. No. Okay, and then I get 1.6 as my coefficient estimates there as well. Okay, so anyway, well, I mean, this is like super basic intro to stats models. There's a lot more examples, such as, you know, if you wanted to do GLMs for like logistic regression, that's you can do that as well. So binomial response data, that's going to be for logistic regression, and they have got examples where you can, I don't know what they're doing here, but you know, you can see the outputs where you got coefficients and estimates of, you know, the p-values for each of these coefficients. So like everything is super significant. That's, I don't even know what this is. What are we looking at? Some kind of data set on education, but I don't know. Okay, that's it. I don't know if you guys had questions regarding next week or things like that with the test and stuff. Yes.
Should we expect a quiz on Monday?
Oh, well, we have no class on Monday.
Oh.
it's Veterans Day. Okay, so no class on Monday, and then yeah, Wednesday. I'm not 100% sure what I'll do. I'll probably spend some time talking about the data that we'll use for Friday's exam, and then the rest of the time I'll find something quick and easy to do. But yeah, no more quizzes. So that's fine. So you'll have your midterm exam, and then yeah, that's it. Okay. All right. Well, we'll see you guys next week then. Enjoy your 3-day weekend, and we'll see you back then.